Yes, good evening once again, children.
Good evening,
Yeah,
ma'am. Good evening, ma'am.
kindly turn on your
Good
camera.
evening.
Good evening, ma'am.
Good evening. Good evening, children. Kindly turn on your cameras. Yes, all of you quickly. We are already late by 10 minutes. I was just waiting for some of them to join. Still about 2 to 3 students have to join the meeting, but it's time, so we have to start the class. All right, I have not shared my screen now. I have not shared my screen. So there was an assignment given to you. Let's discuss the answers and then I'll share my screen. Yeah, 15 by 96. What kind of decimal expansion does it have? 15 by 96.
Terminal decimal expansion.
Terminating decimal expansion. Terminating decimal expansion. Netra, have you completed the homework?
No, ma'am.
Sanjay and Sindhu?
Yes, ma'am.
Okay. All right. So 15 by 96 has a terminating decimal expansion. So Devadarshini was right. Next one, 11 by 24. Anybody can answer? 11 by 24.
Ma'am, can I answer, ma'am?
Yes, yes.
Ma'am, it's not a terminating decimal expansion, ma'am.
It does not have a terminating decimal expansion. 11 by 24 does not have a terminating decimal expansion. Sanjay, next one.
Ma'am, it does not have a terminating decimal expansion, ma'am.
What is the next rational number?
27 by 80, ma'am.
27 by 80.
Yes.
27 by 80.
Does
It
not
has
have a terminating decimal expansion, ma'am.
It does not have a.
Yes, ma'am.
Oh. Okay. And what about 16 by 125?
Ma'am, it's a terminating decimal expansion.
It has a terminating decimal expansion. 16 by 125. Krishmika?
Ma'am?
Have you completed the homework?
Yes, ma'am.
Now tell me what is your answer for 16 by 125?
Terminating decimal expansion, ma'am.
It has a terminating decimal expansion. Okay. And what about for the earlier one, Krishmika? 27 by 80?
Terminating decimal expansion, ma'am.
Yeah, Sanjay, what happened? What are the factors of the denominator?
Ma'am, I did the mistake, ma'am. And the fact is I did the mistake, ma'am. Sorry, ma'am. Ma'am, I too got it's not a terminating decimal expansion only, ma'am.
What are the factors of 125? How do you factorize 125?
Ma'am, for the C, ma'am, third one I'm seeing.
125, third one, 80. Okay. So 80 is what? 80 is 2 to the power 4 into 5, right?
Yes, ma'am.
Yeah, so terminating decimal expansion. How many questions you had on all children?
4, ma'am.
Oh, that's all right.
Yes.
All right. So see the answers. Check where you've gone wrong and get your doubts clarified. I'll share my screen. I'm just about to share my screen. Yes. Is it visible? I've shared my screen. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, children. Now go through this. Go through the answers. You may take a screenshot and then correct wherever you have gone wrong. Correction you can do later. So let me just tell you about all the answers. 15 by 96. All of you listen carefully. 15 by 96. The first step is to write the rational number in the simplest form. The first step is to write the rational number in the simplest form. That is the first step. So 1 minute. Okay, I've used the tables of 3. So 3, oh, I should have written 5 here. No, by mistake, I've written 3. Okay, typing error, children. Sorry. Typing error. That's why. All right. So this is 5, children. 3 5s are 15 and 3. This is 5 here. I'll change it. This is 5. This is 5 everywhere. I made a mistake in typing. Here also. Sorry. Let me do it here for you. 15 by 96. First, write it in the simplest form. You can cancel by 3. So 3 5s are 15 and 3 32 times. I made a mistake while typing, children. Just ignore this. Ignore this one. I've made a mistake while typing. Okay, so 15 by 96. 15 by 96, when you divide by the tables of 3, 3 5s are 15, 3 32 times. So it is 5 by 32. It's 5 by 32. And now take the denominator. First, write the rational number in the simplest form. We are done at 5 by 32. Now take the denominator, 32. We know 32 is 2 into 2 into 2 into 2 into 2, which means it is 5 to the power 5 divided by 2 to the power 5. So the denominator, ignore this, the denominator has only 2 as a prime factor. So the given rational number has a terminating decimal expansion. The denominator can have 2 or 5 or both 2 and 5. The prime factor or the prime factors of the denominator can be 2, 5 or both 2 and 5. So you can see here the denominator 32 has prime factor only 2. It's okay. 2 alone can be there or only 5 or both 2 and 5. So the given rational number has a terminating decimal expansion. Since I've gone wrong here, let me just write it again for you. First, take up the rational number 15 by 96. Write it in the simplest form. 3 5s are 3 32 times. After writing it in the simplest form, take up the denominator. The denominator 32 is 2 to the power 5. Since the denominator has only 2 as a prime factor, see 2 is 5 times, that's okay, but the prime factor is only 2. So since the denominator has prime factor only 2, the rational number 5 by 32 or 15 by 96 has a terminating decimal expansion. Okay. So the denominator 32 has prime factor only 2. Therefore, 5 by 32 or 15 by 96 has a terminating decimal expansion. See the next one, 11 by 24. It's already in the simplest form. 11 by 24 is already in the simplest form. You cannot simplify further. So then take up the denominator 24 and find the prime factors. 2 8s, 2 12s, 2 6s, 2 3s. So it is 2 cubed. 2 cubed into 3. You can see here it's 2 cubed into 3. 2 cubed into 3. 11 by 24 is already in the simplest form. So take up the denominator and find its prime factors. So 24 can be expressed as 2 cubed into 3. 2 cubed into 3. Now you can see that there is this prime factor 3 other than 2 and 5. Other than 2 and 5, there is this prime factor 3. So the given rational number has a non-terminating repeating decimal expansion. But since the question is, does it have a terminating or not? So you must say it does not have a terminating decimal expansion because that's the question. The question is, find which of the following rational numbers have a terminating decimal expansion. So you must not say it has a non-terminating repeating decimal expansion. You must not say that. You must say it has a terminating decimal expansion, or you must say it does not have a terminating decimal expansion, because they're not asking you if it has a non-terminating repeating decimal expansion. So see the explanation here. The denominator 24 has 3 as the prime factor, which is other than 2 and 5. The denominator 24 has 3 as a prime factor, which is other than 2 and 5. Therefore, 11 by 24 will not have a terminating decimal expansion. Will not have, you must say, because the question is, does it have a terminating decimal expansion? No, it does not have a terminating decimal expansion. Am I clear to the class? Am I clear to the class?
Yes.
Yes, ma'am.
What is the first step? What is the first step? When you're given a rational number,
Ma'am, we have to simplify it.
yeah, we must first put it in the simplest form. We must first put it in the simplest form. And then take up the denominator. Find the prime factors of the denominator. If the prime factors are 2, 5 or both 2 and 5, it will have a terminating decimal expansion. If there is a prime factor other than 2 and 5, then the fraction or the rational number will have a non-terminating repeating decimal expansion. Any corrections? If you have to do, take a screenshot and do it, children, because this was homework. Yeah, over to the next slide. 27 by 80. 27 by 80. So 27 by 80, you cannot simplify it any further. It's already in the simplest form, meaning you cannot cancel like. You cannot simplify it, you cannot cancel like this and simplify any further. So then take up the denominator. That the first step is to simplify. It's already in the simplest form. Okay, then take up the denominator. These are the prime factors. This is how you factorize 80. 80 can, how do you find that doubt should not be there? But in case you have, disable your mic. Somebody's mic is enabled, please disable your mic. So 2 40 times, 2 20 times, 2 10 times, 2 5s and 5 1s. So it's 2 to the power 4 into 5. 2 to the power 4 into 5. So what are the prime factors we see? We see 2, we see 5, we see only 2 and 5. See, there can be only 2, only 5 also. That's also fine for terminating decimal. Only 2, only 5 or both 2 and 5. So 27 by 80 is already in the simplest form. Take up the denominator 80. Express, write 80 as a product of its prime factors. 2 into 2 into 2 into 2 into 5, which is 2 power 4 into 5. So the prime fact, forget the numerator. Numerator can have anything as prime factors. Don't see the numerator, only denominator. The prime factors are only 2 and 5. So see the explanation. The denominator 80 has 2 and 5 only as prime factors. The denominator 80 has 2 and 5 only as prime factors. Therefore, the rational number 27 by 80 has a terminating decimal expansion. And finally, 16 by 125. It is already in the simplest form. You try to cancel, you cannot cancel any further. It's already in the simplest form. So take up the denominator. Take up the denominator. 125. 125. Sanjay went wrong here. So maybe you use 3. So 5 25 times 5 5s are 5 1s are. So 16 by 5 cubed. See, there is no, you'll ask me, there is no 2. It's okay. You can write into 2 to the power 0. It's okay. It's not that both 2 and 5 should always be there. There can be only 5. Prime factor 5 or the prime factor 2 or both the prime factors 2 and 5. So the denominator 125 is 5 cubed. 5 cubed. 125 is 5 cubed. So the denominator 125 has no prime factors other than 5. It has no prime factors other than 5. Therefore, 16 by 25 has a terminating decimal expansion. Yes, children. These are the answers to the homework questions. Now, test. Okay, take a screenshot. Quickly. Udanshri, is it clear?
Yes, ma'am, it's clear, ma'am.
Okay. Yeah, Sanjay, any questions, Sanjay?
No, ma'am. No doubts, ma'am.
All. Yeah, class, the last two, quickly. 21 by 112. Work that and tell me. 21 by 112. What kind of decimal expansion it has? Do it now, all of you. Take the question.
Ma'am, it has a non-terminating decimal expansion.
Non-terminate. Okay, let me wait for the others to answer. (21 by 112). Danya and Jayant, could you please turn on your video? Yeah, others. No, it doesn't take this long, children. Done? What's your answer, Arjun?
Ma'am, 1 minute, ma'am.
Okay.
Ma'am, can you show the question for 1 minute?
Yeah. All right. What is your answer, children? Why only Madhumita shared? What about the others?
2 per 4.
Yeah, somebody said something. Netra, is it?
Ma'am, 3 by 2 per 4.
3 by 2 to the power 4.
Yes, ma'am.
Very good, Netra. Yes. Go on. 3 by 2 to the power 4. Yes. What is your comment? What kind of decimal expansion? What do you see? Yeah. What is the prime factor you see in the denominator?
16.
No. What is the prime factor is only 2, right?
Yes, ma'am.
So only 2 means terminating decimal expansion, correct?
Yes, ma'am. Yes, ma'am.
Okay, very good. Yes.
Ma'am,
So children,
Ma'am,
You can see the answer. You know it's time. See the answer. So you must first simplify the given rational number. So 7 threes are 21, 7 ones are 7, 7 six are 42. See now, supposing you feel, how, if you should know, see simplification, how else can I help you? Or, if supposing you forgot to do it also, fine, let me give you the answer and then talk about the others. Now 21 by 112. So the first thing is you should simplify. 7 tables, 7 threes are 7, ones are 7, 7 six are 42. So the simplest form of the rational number is 3 by 16. And now it's 3 by, as Nedra said, 2 to the power 4. So the denominator 16 has no prime factor, no other prime factor, or you can just say no prime factor other than 2. Therefore, 21 by 112 has a, see, 3 by 16 and 21 by 112, both are the same. Therefore, 21 by 112 has a terminating decimal expansion. That's all. Why is it so difficult?
Ma'am, I actually forgot to simplify, so I got the wrong answer, ma'am.
Yeah, that is what is very crucial here. See, when you don't simplify, we'll end up with an incorrect answer. So if supposing children, you forgot, now when you found the prime factors of 112, 56 times, 228 times, 2 14, 2 sevens are, 7 ones are. So now 21 by 112, okay, is 21 by, can you see the 7 there in the denominator? Immediately you must realize, oh, there is 7 in the numerator also. 21 is 3 sevens are 21, and the denominator 112 also has 7 as a factor. So we should immediately simplify. See, when you find the prime factors of 112, you're finding 7 there. So immediately you must realize numerator 21 also has 7 in it. So you must simplify. Because 21 and 112 have a common divisor 7. Write down this answer, children. The denominator 16 has no prime factor other than 2. Yeah, tell me the next one.
It does not have a terminating expansion.
Yeah, it does not have a terminating decimal expansion.
Non-terminating decimal.
No, we should not say that. We must say it does not have a terminating decimal expansion. Yeah. And see for 11 by 35, you can see the steps there. 11 by 35. Oh my God. Here also it's 11 children.
Ma'am, but in the question slide I saw 4, ma'am. 4 by 35, ma'am.
Okay, okay,
Yes,
okay. Fine. Whatever. All right. So let me
Ma'am,
check.
can you show that slide for a second?
Which one?
Ma'am, that last question.
Yeah.
Yes. Yeah, ma'am. Yes. Okay, ma'am. Thank you, ma'am.
Yeah, tell me, children, what kind of decimal expansion do rational numbers have? What kind of decimal expansion do rational numbers have?
Terminal decimal expansion, non-terminal non-terminal recurring decimal expansion, non-terminal non-recurring decimal expansion.
No, it's not terminal, it's terminating. Terminating. Okay, no, but my question is, what kind of decimal expansions do rational numbers have? What kind of
P
rational?
by Q form.
No, what kind of decimal expansion?
Not terminating, repeating,
Terminating
and
and
terminating, non-repeating decimal.
Non-terminating recurring decimal expansion.
Terminating and?
Non-terminating.
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 Yes, Diane, tell me. Terminating decimal expansion and?
Non-terminating decision.
Non-terminating repeating.
Non-terminating repeating this expansion.
Okay. All right. So see the question here. Insert 5 rational numbers between. So what do you mean by rational numbers? They can be terminating decimals. When insert 5 rational numbers.
Which are in P by Q form.
Yeah, exactly. 5 rational numbers meaning you can insert terminating decimals or non-terminating repeating decimals. And then you must put them in the P by Q form. Insert 5 rational numbers between these two. So rational numbers means you must insert a terminating decimal or a non-terminating repeating decimal and put them in the P by Q form. Rational number always has a P by Q form. Put them in the P by Q form. Okay, take up the first one. 0. Yeah, start writing, children. 0 and 0.1. Now, see here. Does this lie between 0 and 0.1? 0.01? 0.01, 0.01, 0.001, 0.00001, all this lies between 0 and 0.1. Or you can say 0.02, 0.002, 0.03, 0.07. You just, to be safe, just start with a 0 because you need to insert between 0 and 0.1, between 0 and 0.1. So what we do is 0.01, 0.02, or you can say 0.0003. All these numbers, so when you take 0.003, it lies between 0 and 0.1. It lies between 0 and 0.1. So 0.01, 0.03, and then say 0.05, 0.07, 0.09 are 5 rationals, are 5 rational numbers, between 0 and 0.1. Now we should write them in the P by Q form. You must put it in the P by Q form. So that means this implies 1 by, what is 0.01? 1 by 100, correct? 0.01 is 1 by 100. 0.03 is 3 by 100. 5 by 100. 7 by 100. 9 by 100. Now, whenever you have to, whenever it's possible to simplify, you must simplify. So you can cancel this 5 ones are 5 20s are. So these are 5 rationals. These are 5 rationals or rational numbers between 0 and 0.1. Between 0 and 0.1. Write down, children. Now, I have taken 1, 3, 5, 7 so that, we don't have the simplifying job. If you write 0.02, then you have to simplify 2 by 100 and then you have to simplify. So when you take numbers like this 3, 7, 9, you don't have to simplify. You can just leave it as a fraction. 0 and 0.1. You can write many numbers. There are infinitely many rationals lying between 0 and 0.1. Write down, all of you.
Completed now.
Yeah. All right, let's see the next one. This is over, children.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yeah.
Yes, ma'am.
Tell me the next one. Tell me the 5 numbers between 1.3 and 1.4. 1.3 and 1.4. So you should treat it as 1.30. Just treat it as 1.30 and 1.40. Treat 1.3 as 1.30. Treat 1.4 as 1.40. Now this is like 30. This is like 40. So 1 point, see, this is 30. This is like 30, 30, 40. So 1.31, 31, 1.32, 32, 1.33, 1.34, 1.35, 1.36. Like this, you can go on up to 1.39. Do we understand what? Don't write this. Do we understand what I've written?
Yes, ma'am.
1.3 and 1.4 can be treated as 1.30 and 1.40. So this like 30 and this like 40. So between 30 and 40, what do you have? 31, 32, like this, you can go till 39. Now somebody tell me, is this correct? Can I treat 1.3 as 1.300, 1.300?
Yes, ma'am.
And can I write 1.4 as 1.400?
Yes, ma'am.
Ma'am.
Must have the same number of digits after the decimal point. You must have the same number of digits after the decimal point. You must have the same number of digits after the decimal point. So now between 300 and 400, what are the numbers between 300 and 400?
0.1, 0.2.
1 point.
1.01.
1.301,
301, 1 point.
302, 1.303 goes on.
So on like this, we can write till 1 point.
309, 1.309.
309,
399.
399, ma'am. Right till 1.399. 301, 302, 303, 304, 305, 310, 320, 330, because between 300 and 400. So starting from 301, you can write up to 399. You can also treat 1.3 as 1.3, 1, 2, 3 zeros and 1.4 as 1.4000 like this. Do we understand? You can also treat it like this. See, we are increasing the space between the two numbers. When it was 1.3 and 1.4, there's no, it's like we feel there is nothing. How can I insert 1.3 immediately 1.4? How can I insert? So you can widen the space between them like this by adding zeros. You can widen the space between them by adding zeros like this. So you can treat 1.3 as 1.3000 and 1.4 as 1.4000. You must have the same number of digits after the decimal point. Now between 3000 and 4000, what can you write? 1 point. Give me this first value.
3001.
Then 1 point.
3002.
Okay, next 1 point.
3003.
Like this, we can go up to 1 point.
1.399.
We can go up to this. We can go up to this. This is the P by Q form. How do you write this in the P by Q form? One 3001 divided by 1000 or 10,000. 4 zeros. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Yes or no?
Yes, ma'am.
And supposing you want to write this in the P by Q form, 13999 divided by 1 followed by 1, 2, 3, 4 zeros. Okay, now I'll write the answer for you. I hope we understood. All of us understand that?
Yes, ma'am.
Yes, ma'am.
All right. So 1.3 and 1.4. So you can treat it as, see, this is enough. 1.30, 1.40 is enough. Or you can treat it as 1.300, 1.400. Or you can treat it as this number and this number. That's completely your choice. I'm going with the first one. Okay. So 1.3 is also 1.30. 1.4 is also 1.40. So 1.31, 1.3. Now I'll not write 2 children because then I have to divide, no? So I'm just trying to take numbers that end with an odd digit so that simplifying work can be reduced. See, sometimes you may have to simplify even then. So I'll just take numbers like this 1.33, 1.35, 1.37, see like 31, 33, 35, 37, 39, 1.39. Are 5 rationals. Are 5 rationals between 1.3 and 1.4. Between 1.3 and 1.4. So that implies 131 by 100, 133 by 100, 135 by 100, 137 by 100, 139 by 100 are 5 rationals. 5 rationals between 1.3 and 1.4. Now you can simplify this. You need to simplify this in the tables of 5. 5 2s are 10, 5 7s are 35. And this one is 5 20 times. 27 by 20. Is it clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. Please complete, children. So this is how we insert rational numbers between two given rationals. Done, children?
Yes, ma'am.
Is it fine, children?
Yes, ma'am.
Yes, ma'am.
Now you help me with the third one. You can help yourself. We've been doing it since, okay, not since. You know it in 8th standard also, how to insert rational numbers between, 3 by 8 and 2 by 5. So that's homework. Yeah, now tell me between, this is also homework, all about last year. Yeah, tell me, children, D between -1 and half. Between -1 and half. Rational numbers between -1 and half. Where is -1? This is 0, this is 1, and this is half. So between -1 and half. Can you write? Let me make it like this. Will you find -3 by 4 here? Minus half here, minus quarter, half, 1. Is this correct? Now you can see 0 here, you can see 0 here, you can see -1 here, you can see 1 here. Between 0 and -1, we have minus quarter, there are many more. But what we easily understand, minus quarter, minus half, -3 by 4. So you can write -3 by 4, minus half, minus quarter, 0, quarter. These are 5 rationals between -1 and half. I'll show you the number line again, children. I'll show you again. See here. Number line. All if you look at the screen. All if you look at the screen. Zero. Am I right? 0. 1. -1. Is this understood?
Yes, ma'am.
Now between 0 and 1, do we have half?
Yes, ma'am.
Between 0 and -1, do we have minus half?
Yes, ma'am.
Yes, ma'am.
Between -1/2 and -1, do we have -3/4?
Yes, ma'am.
Yes, ma'am.
Between 0 and -1/2, do we have -1/4?
Yes, ma'am.
And now between 0 and half, do we have positive 1/4?
Yes, ma'am.
That's what. That's nice. This one 1, 2, 3, 4, 5. So -3/4, -1/2, -1/4. And disable your mics. And 1/4 are 5 rationals. Are 5 rationals between -1/2. All of you write down.
Ma'am, with the number line we have to write down, ma'am.
Whatever you see on your screen now, right? What you see on your screen.
Number line.
Number line I just used it to explain. You can also represent that in your book. Yes. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Okay, children. Thank you. So 2 and 3. So between 2 and 3, so write 2 as 2.0. 2 is equal to 2.0. And 3 is equal to 3.0. So what you have? You can write 2.1, 2.2, 2.3, 2.4, 2.5. You know, right? Between 2 and 3. Between 2 and 3, we have 2.1, 2.2, 2.3, 2.4. You can write up to 2.9. Then if you treat it as 2.00 and 3.00, you can write many numbers. There are infinitely many rationals lying between any two rationals. So 2.01, 2.02, 2.03, 2.04, like that you can go on till 2.99. 2.99. Between 2 and 3. It should be between 2 and 3. Lying between 2 and 3. 2 and 3. So 2.1 is more than 2 but less than 3. 2.3 is more than 2 but less than 3. 2.5, 2.7, 2.9 are 5 rationals between 2 and 3. Then put them in the P by Q form. So 21 by 10, 23 by 10, 25 by 10, 27 by 10, 29 by 10 are 5 rationals. Are 5 rationals between 2 and 3. between 2 and 3. So now cancel. 5 5s are 5 2s are. Whenever simplification is possible, you must simplify. Write down, children. The rest of the questions, please try them as homework. .1, 2.3, these numbers are more than 2 but less than 3. You can write many such numbers, children. The collection is unlimited. You can write 2.9991, 2.9992, 2.9993. See, all this is more than 2 but less than 3. You can write 2.0909. Whatever you can imagine, more than 2 but less than 3. So 2 point something will be more than 2 but less than 3. You cannot write 3.1 because that will be more than 3. The collection is unlimited. Finish writing, children?
Completed, ma'am.
Very good.
Yes, ma'am.
Completed, ma'am.
Yeah. Rest of the questions, homework, children. Let me see how you try them. Next. Now let me again ask you. Let me again ask you. What are the two types of decimal expansion a rational number has?
I'm terminating this.
Terminating and
Terminating.
Non-terminating.
Terminating decimal expansion and non-terminating repeating decimal expansion. And what about an irrational number? Non-terminating, non-repeating. Okay, now I'm going to show you some decimals. Tell me. Be careful. Udanshri, this question is for you.
Yes, ma'am.
Jayant,
Ma'am?
are you in the meeting using a laptop or a mobile phone?
Ma'am, mobile, ma'am.
Okay, place it in a position, no, because your video, I just want to see your face.
Ma'am, it is a place on place, ma'am.
No, but your video is going on changing.
Okay, ma'am.
Don't keep handling the phone, you know, just leave it to rest in a place. Yeah, let it be like this. There should be no change in your video.
Okay, ma'am.
I think you are lifting it to keep it closer to you and write the answer. That's when the video changes, correct?
Yes, ma'am.
Yeah. In that case, you turn off your video, Jayant. If you're using a mobile phone and you have to lift it every time to write, you turn off your video.
No, ma'am, tomorrow I come in laptop, ma'am.
Okay, fine. So today you turn off your video then. Or you keep
Okay.
it in place.
Okay, ma'am.
Yeah. Yeah, children, now answer this very carefully. Udanshri,
Yes, ma'am.
what kind of a decimal expansion is this?
Non-terminating.
Oh, you must be specific, non-terminating.
Ma'am, can I say, ma'am?
Udanshri.
Yes, ma'am. Ma'am, can you hear me?
Yeah, non-terminating.
Non-terminating repeating decimal, ma'am.
What is the other way of writing this? How can I write this one? 1 point.
Ma'am, 3
3
bar, ma'am.
bar.
Yes.
1.3, yeah. Can I write this one? Can I write this as 1.3 bar?
Yes, ma'am.
Yes. Children, the second one. This one is a non-terminating repeating decimal. What about this one, children?
Ma'am, non-terminating, non-repeating decimal.
Ma'am, it's a terminating decimal.
Ma'am, it's
Terminating decimal, ma'am.
It's a terminating decimal. It's a terminating decimal. See, even now, in chorus, all of you should have given one answer. Now also you're going wrong, some of you. What is this? 1.3333 like this going on forever. This one means non-terminating, non-terminating and repeating because 3 is repeating. This can be written as 1.3 recurring. But when I say 1.33333333 and I stop here, I stopped. I did not use the dots. I did not do this. This one is a terminating decimal and this cannot be written as 1.3 recurring because it doesn't recur. It stops. It stops here. I cannot write this one as this. This is a terminating decimal. Only non-terminating repeating decimals are written like this. Is that fine, children?
yes, ma'am.
Okay.
Yes, ma'am.
All of you listen to this very carefully. Now we are learning we're going to learn how to write a terminating decimal and a non-terminating repeating decimal in the P by Q form. Listen very carefully. No questions in the middle. At the end of the explanation, you can get your doubts clarified if you have any. So A, 0.235. Is equal to, this we already know, 235 divided by 1 followed by 3 zeros. Isn't it, children?
Yes, ma'am.
Yes, ma'am.
0.235 is 235 by 1000. This we already know. This we already know. Now what should you do after this?
Ma'am, we should simplify.
Simplify. So 5 fours are 20. 5 fours are 23, the remainder 5 7 are 35. And here 5 200 times. So 47 by 200. The P by Q form, that's all, we finished. The P by Q form of 0.235 is 47 by 200. That is, if you divide 47 by 200, the answer, the quotient will be 0.235. The remainder will be 0. When you divide 47 by 200, the division will come to an end with a 0 remainder and the quotient will be 0.235. Take down. This is the P by Q form of 0.235. Take down, children. Write the heading, express in P by Q form. Express it. Yeah. Express in P by Q form.
Completed, ma'am.
Yeah.
Completed, ma'am.
Danya, are you there, Danya? You're normally a very active participant. Why no responses from you? Are you there, Danya?
Yes, ma'am.
All right. Are you following, Danya?
Yes, ma'am.
Okay, you did you watch the recordings which I shared?
Yes, ma'am.
All right.
Ma'am, actually today I'm not feeling well, ma'am. That's what.
Oh, okay, okay. Take care, take care. All right. Now the most important thing, the same thing, we are doing A only. The second one, how to write 0.23. The next question is a test. Listen very carefully. 0.235 recurring. All right, children, are we ready? Only 3-5 recurring, children. Only 3-5 recurring. 0.235 recurring. Only 3-5 recurring. That means it's 0.235, 35, 35 going on forever. Only 3-5 is going on forever. Shall we begin?
Yes, ma'am.
Yes,
Okay.
ma'am.
So first you must say let x be equal to 0.235 recurring. This is the first step. So that means this implies x is equal to 0.235, 35, 35, 35. How many ever times? See, supposing you write only 1, 2, 3 times. That's also enough. How many ever times? Some 2, 3 times you write recurring. You should not forget to say it's recurring like this. Is this understood? Let x be equal to 0.235 recurring, and then we write it in the recurring form using, the repeating digits 2-3 times. How many digits are repeating?
2 digits are repeating.
2 digits.
2 digits.
2 is not repeating. No, so only 2 digits, 3 and 5. Only 2 digits, 3 and 5 are repeating. So how many digits are repeating? 2 digits are repeating. Then we should find 100x. See, listen carefully. If 1 digit repeats, you must find 10x. If 1 digit repeats, you must find. No, see, I'm telling you, I don't want girls and boys to, keep adjusting their hair. Don't do that. I'll remove you from the meeting. I'll remove you from the meeting. No meddling with the hair. There's nothing. You just have to reach out. If you have to drink water, reach out for your water bottle. No adjusting hairstyle. Girls and boys, no adjusting your hairstyle. Fasten your hair. Fasten your hair. That's very, very important. I don't want your hand to run through your hair. And don't wiggle like a worm. Don't wiggle like a worm. Yeah, please get that right, children. I don't want to repeat this instruction. Yes, let's get back to the answer. So children, how many digits repeat? 2 digits are repeating. 2 digits are repeating. If 1 digit repeats, find 10x. If 2 digits repeat, see if 1 digit is repeating, 1 digit, then you should find 10x. Only 1 0, 10x. If 2 digits repeat, find 100x. If 3 digits repeat, find 1000x, and so on. Now, how many digits are repeating? 2 digits are repeating. So you should next find 100x. Because 2 digits, 3 and 5 are repeating, 2 digits. 2 digits are repeating. So that means 100, 2 zeros. You should find 100x. If 1 digit repeats, you must find 10x. Okay, so now since 2 digits are repeating, next we'll find 100x. 100x is equal to, that means you should multiply x with 100. What will you get when you multiply x with 100? That is 0.2353535. Going on like this, if you multiply by 100, what will happen? This decimal point will shift. 1, 2, it will come here. It will come here. So 100x will be equal to 23. See, I'll show you again. It's the regular multiplication. It's the regular multiplication. Now, let me ask you something else. Let me ask you something else. What is 2.3576 into 100? What's the answer? What is the answer for this?
235.76, ma'am.
235.76. You'll know that is 1, 2. 235.76. Same thing we're doing. Same thing. Nothing different. Same thing. How do you usually multiply by 100? The same thing. So you're multiplying 0.2353535 going on forever. You're multiplying this by 100. Why? This is only x. This is x. X 100x means what? Whatever is x, you multiply by 100. Whatever is x, you multiply by 100. That is what is 100x. So when you multiply 1, 2, it becomes 23 point. So it becomes 23 point. What does it become? 23.5. 35, 35, 35 going on. How many more times you can write this 35, children? Do we understand? See now,
Yes,
don't
ma'am.
ask me. I've written 3, 5 here 4 times, here 3 times. See, 3, 5 is going on forever. You write it 4 times, 5 times, 6 times. One of you will write it 4 times, another will write it 5 times. It's okay. It's going on forever. You write it how many times you want. So some 2, 3 times we normally write. Okay, 4 times. So there's nothing. Disable your mic. Okay, so this is what it is. So we said x is equal to the given decimal. X is equal to the given decimal. Then since 2 digits 3 and 5 are repeating, we find 100x. We find 100x. 100x will be whatever is x.
Excuse me, ma'am, I have a doubt.
Yeah, no, let me finish it, please. I'll get back to the Madhumita. I'll just finish it.
Yes, ma'am.
Yeah. So 0.2353535 is going on forever into 100. This is x into 100. So 1, 2, 23 points here, 23.5, 353535. See 23.5, then 353535. So 23.5, 353535. Should be very careful there while multiplying. So we call this equation 1 and this one equation 2. Now we are going to do equation 2, the bigger equation minus the smaller one. Equation 2 minus equation 1. So let me write equation 2. 100x is equal to 23.5353535 goes on. I can write another 35 also. Now you cannot ask me, here you wrote only 3 times, why you're writing 4 times here? See, that's okay. I'm telling you again and again. You can write 35 how many ever times you want. Going on like this, going on forever. This is equation 2. Now equation 1 is x is equal to, write it carefully, 0.0. I should write it like this, place the decimals correctly, the decimal point correctly, 0.2353535 going on forever. This is equation 1. Is this understood? Write 100x first and then x. Now you'll ask me, here in x we have 35, 35, 35, 4 times. Why you have written only 3 times here? I told you, that's what. You don't count that. That is going on forever. You write how many ever times you want. I wrote it only 3 times because above I have 3 times. Above I have 3 times, so I wrote 3 times here also. That's all. Going on forever. Place the decimal point carefully. I've written 100x and then x. Now subtract. Now subtract. What will you get? 100x minus x is 99x is equal to. Now here when we subtract, this portion is going on forever. The same thing is going on forever. So they get cancelled. You'll get 0, 0, 0, 0. When you subtract, you will get 0, 0, 0, 0, 0, 0. That means you can just cancel this portion. And now 5 minus 2 is 3.23. So 99x is equal to 23.3. Please write down till here. Write down till here, children. Yes, Madhumita, you can ask your doubt on this slide.
No, ma'am, I understood it after you explained the whole thing, ma'am.
Okay, darling. Okay, darling. Yeah, thank you. Yes, children, please finish it till here. Write mindfully, don't blindly copy. Put your mind into your work and write. Finish writing, children, till here.
Yes, ma'am.
Yes, ma'am.
So first, assign the given value to x. Let x be the given value. Then you write x. Take away that bar and write the decimal value using the dots. 0.2353535 going on forever. Take out the bar and write it. Then count how many digits are repeating. 2 digits. So we have to find 100x. If 3 digits repeat, find 1000x. Like that. Now you have x and 100x. Equation 1 and equation 2. Now subtract equation 2. Perform equation 2 minus equation 1. So you should write the equations one below the other carefully. The decimal point, please make sure that it falls one below the other. Then subtract. See, subtract. I didn't change the sign here. Here also a minus sign, children. Please put a minus sign here also. Subtract. 100x minus x is 99x. Now here, this recurring part, they get cancelled because in the first equation also 3, 5 goes on forever. Meaning this equation, it goes on forever. Here also 3, 5 is going on forever. So that will get cancelled. Meaning when you subtract, you'll get 5 minus 5, 0, 3 minus 3, 0, 5 minus 5, 0. So 0 only you're getting. So you can ignore that. Now 5 minus 2 is 3. This decimal point, 23 minus 0 is 23. I have to clear the slide. Is it understood? Any doubt in this slide?
No, ma'am.
No, ma'am.
No, ma'am.
Krishmika, is it clear?
Yes, ma'am.
Sure. All right. So 99x is equal to 23.3. From there, we have to continue. 99x is equal to 23.3. So I'm continuing. Please continue in your book. 99x is equal to 23.3. What happened?
Ma'am, when one number is repeating, we want to use 10x, ma'am.
Yeah, 10x.
Okay.
Yeah, very good. So now tell me what should I do after this? 99x is equal to 23.3. Then after this, x is equal to
23.3 by 99.
no one. Yeah, you're right. But before that, what is 23.3? Can I write it as 233 by 10 children?
Yes, ma'am.
Yes, ma'am.
I'll first take away the decimal point. So 99x is equal to 233 by 10. So now x is equal to 233 by 99 into 10. Now to simplify is your job. That's not my job. If you should check if it can be simplified. Or I'll just tell you how you should do it every time. 99 is divisible by 3 and 11. What is 99 is divisible by 3 and 11. Prime factors you must take. Not all. Now 99 is also divisible by 9. No, the prime numbers we are talking about. 99 is divisible by 3 and 11. So check if 233, the numerator 233 is divisible by 3 and 11. That's all.
Ma'am, it's not divisible by both the numbers.
Then it's in the simplest form. 99. Okay, let me finish the answer. So 233 by 990. This is the, what is x, children? Go back to the starting. What is x? X is 0.235 recurring. Didn't we say that? Let x be equal to 0.235 recurring. Didn't we write that? Yes, please respond.
Yes, ma'am.
We wrote x is equal to 0.235 recurring. Now what we are getting for x? X is equal to 233 by 990. This is what we are getting. This is what we are getting. So this is the p by q form of this number, rational number, of this non-terminating repeating decimal. The answer ends here, children. This is rough work. This is rough. Don't write this. The answer ends here. The question is to find the p by q form. The question is to find the p by q form of the given non-terminating repeating decimal. This is the decimal form. Sorry, this is the p by q form. Please understand the question. What kind of decimal was given to you? What kind of decimal was this? 0.235. What kind of a decimal is this?
Terminating decimal, ma'am.
Terminating decimal. Terminating decimal. What is its p by q form?
Ma'am, 235 by 1000.
What? Look into your book and say.
I'm 235 by 1000.
235 by 1000.
What's the p by q form you got?
47 by 200.
47 by 200.
47 by 200.
200.
For this this is the terminating decimal and this is its p by q form. The next decimal, what kind of a decimal is it? The next one. It's a non-terminating repeating decimal. It's a non-terminating repeating decimal. Which one? This one. This one. The next one is a non-terminating repeating decimal. What is its p by q form? 233 by 990. If you use the calculator and find 233 by 990, you will get 0.2353535 going on. You try this on your calculator. 233 by 990, you will get 0.2353535 going on endlessly. Yeah. So about the simplification, the answer ends here, children. About the simplification, I said 99 and 233. 99 is divisible by 3 and 11. Prime numbers 3 and 11. So check if this is also divisible by 3 and 11. If it's not divisible, that means it's in the simplest form. It is in the simplest form. Is it understood?
Yes, ma'am.
Yes, ma'am.
All of you finished writing?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. So now tell me, what will you do with 0.175 recurring? What will you do with this one? 0.175 recurring. You will say let x is equal to. Is this correct?
Yes, ma'am.
Yeah, after this, will you multiply? Will you find 10x, 100x, 1000x?
1000x, ma'am.
1000x. You should find 1000x. What will you get for 1000x? When you multiply by 1000, 1,
75.
3. Here, the decimal point will move. 1, 2, 3. It will come here. So what is 1000x? 175 point. How many times should I write 175 here? How many times should I write 175 here?
Ma'am, it's non-terminating repeating decimal, so it keeps going on, ma'am.
Yeah, so it's my choice. Whether I should write it 2 times or 3 times is just my choice. Don't get scared there, children. Don't ask yourself how many times I should write 175. You write it 3 times, 4 times, fine. I'm just quickly doing the second one. You try it later. I'm just doing it quickly. So let x is equal to 0.175 recurring. That means x is equal to 0.175, 175, 175 going on like this. Next we find 1000x, which is 175 point like this. It goes on like this. Now we should subtract. We should write 1000x, this equation first. We must write this equation first, and then we must write x equation. Write it carefully. Don't write 0.175, 175 going on. So here when you subtract, what happens? When you subtract
999x, ma'am.
999x is equal to, after the decimal point, this will just get cancelled because the same thing we have after the decimal point, same thing. So they'll just get cancelled. 175 minus 0 is 175. So x is equal to 175 by 999. This is the P by Q form of 0.175 recurring. I just did it quickly so that you feel comfortable to do the homework. That's all, children. So it's all about subtracting. You should have one x equation and then you will have one 10x or 100x or 1000x. You'll have one other equation like this. You must subtract the two equations. This is the format. One x equation and then one 10x or 100x or 1000x. Accordingly, you will have. Then write the two equations one below the other, subtract and get the P by Q form. Isn't it easy?
Yes, ma'am.
Yes,
All
yes,
right, children? All of you? Now class, use the emoji, raise your hand. Sanjay, Sindhu, Udanshri, Devadarshini, Madhumita, Raja, Netra, Krishmika, Jayant, and Arjun. Very good. All right, children, take a screenshot of this. The rest of the question, please try it as homework. We'll discuss the answers in the next class. Take a screenshot. The rest of the questions in B, C, D, and E. Oh, B, C, D, E, F. Homework.
okay, ma'am.
Children, see, be careful. This one is just 2314 by 100. That's all. 23.14 is just 2314 by 100. And then you simplify. That's all. That's the P by Q form. For 23.14 recurring, you should use the X method. The X method is for this recurring. 23.14 is simply by 100 like this. Here also 1.239 is 1239 by 1000. For this one, you should use the X method. Now tell me, what will you find for this? Will you find 10x or 100x? What will you find for this?
1000x, ma'am.
1000x.
Ma'am, we don't.
What will you find for this one? How many digits are repeating?
10x.
Yeah,
10x, ma'am, because there's a bar only.
10x.
It has bar on only 9, ma'am.
Who first said 10x?
Yes.
Netra, is it? Netra, you said 10x?
Yes, ma'am.
Very good, very good. Yes. 10x you should find. You must find 10x. What did I say? How many digits are repeating? Only 1, 9. So it's enough to find 10x. See, you're saying 239. After the decimal point, there are 3 digits. No, not that. 1.239 recurring. Only 9 recurs. Only 9 recurs. So 10x. 1 digit only is repeating. So 10x. Is it understood, children?
Yes, ma'am.
Yes, ma'am.
Yes,
Now,
ma'am.
what will you find? For this, what will you find?
100x.
100x.
X. Very good. All right, children. So that's it for today's session. Thank you so much.
Thank you.
Meeting. Yeah, thank you, children.
Thank you.
Yeah, please complete the homework. Have you all taken a screen?
Thank you.
Please take a screenshot of homework.
Yes, ma'am.
All right. Thank you, children.
Thank you.
Thank you.
Thank you. See you.